Hello guys, welcome. This is tutorial on mathematics. Now for those of us that we are coming in for a new session, the GS3 moving into new class ss1, the ss1 moving into new class ss2, and the ss2 moving to a new class which is ss3. Now this tutorial is going to be based on mathematics and other subjects. Now I will start from ss1, then ss2 and ss3. So for each week, the topic you will be that they will teach you in school, I will take you here. So you have an understanding of it before you go into your classes or before your teacher teach you. Now, the first one, ss1, we have this is the scheme of work for ss1, revision of last term notes. I will attach these notes to the description or the first comment on this video, so you can download this particular scheme of work and the notes attached to it. So you have the soft copy. As I'm solving something, then you will use your notes also to back it up, so that you have a complete knowledge of what I'm taking you. The first week is revision of basic operation. These ones are addition and subtraction. I'm not going to take this first week something. Your teacher will do that for you. It's just revision of what you did in your GSS3 class. Now, the second week we have number base. Now, this number base, this is the second week we are going to look at here. From number base, then to this particular base to another. We are going to solve it. We go through the note, then we solve it one after the other. By the end of this class, you understand everything on number base and possible question that you will be asked in Y, or you may be asked in WAEC or GCE. So this is the scheme of work. I won't go deep into this scheme of work to save us time. Now the reference book I'm going to use, the books I'm going to use, if you have it, you had Mathematics for Senior Secondary School 1, then Essential Mathematics for Senior Secondary School by Oluwasomi. For most of us using general mathematics a lot. Then exam focus also, if you have it, if you have any of the textbook, you can check the number based system there. After you learn this particular topic from me, you can now start solving some questions under it. I believe me, you will be very good, and you'll be very smart in doing it. Now, what is the learning objective for this particular tutorial? We are going to look at definition of number system. Number, how do we define it? What is it all about? Definition of number based system, types of base number, conversion from other base numbers to base 10 numbers, conversion from base 10 numbers to other base, fractional base numbers, conversion from decimal to decimal, solving for an unknown in a number base. This is not new to you. You did it in your GSS1, even in primary school. From these types of there in primary school or your GS1 is binary numbers. Most time it's binary numbers, and let's say just base 3, just small numbers. But in SS1 we are going to go more advanced in it, but no problem about that one. So let's go on. So what is number based system? Believe me, I'm still going to solve. I just want you to understand the notes. So it's not about you reading alone, but we should go along with each other. Now, a number system is defined as a system of writing to express number. Yes, it's just like when you just write, like someone said, okay, write 55 for me. Write 55. Write 627. You write 627. Okay, write 62 plus 3. 62 plus 3. You write it. So these are number system. It's just the way of representing numbers. The same thing like when you have in English, what are vocabularies or all these things. So how do you represent these things? So the same thing with mathematics. Mathematics we deal with numbers. We deal with operation, arithmetic operation. We deal with a lot of sign, mathematical sign. So number system is just the way of representing numbers. And unless it is specified, all number system is in base 10. They are always in base 10. So if I give you 55, it is in base 10. If I give you 100, it is in base 10, unless it is stated otherwise. Now, the value of any digit in a number can be determined by the digit. Yes, digit, or what digit were you given? How do you know the digits? If I given 431, that is 431. Is then from giving 43. 43 is just 4 and 3. So the digits we are given is positioned in the number. So if for example, let me bring out my Jamboard. Now, when you have this, let's assume now you're given something like this. Sorry, you're given like this 4, 3, 1. Now the position of this 4 here is 100. Now this one is units, this is tens, this is what, this is on, that is what position is talking about. This number is 431, and it is ordinarily, unless it is stated, it is in base 10. It is a small 10 at the bottom of it. So if you didn't see that, so that is what base number is talking about. Now next one was the base of the number. I told you that ordinary number, except it is stated otherwise, it is in base 10 number. That does not mean that in some cases you will see something like this. You will see something like this. Somebody, a teacher, you may see something like this: 2, 4, 1, base 3. It's possible. It means this one is in base 3 number. So you can, but ordinarily without stating any number at the bottom, is in base 10 number. So that is that under that one. Now, what is now number-based system? Now, number-based system, base number is the base of which each place value column in a number system or the collection of numbers to which one or more other numbers are appended or added. You will look at this. So don't be confused. Now, for example, now if you are given something like this, let's assume somebody give you something like this. They say you should expand it. You are given something like this. You are given 2. So you are given 2, 5. Then you are in base, let's say base 6. Then I say you should expand this thing to base number. So if you want to expand it now, you are going to use this 6 to multiply each of these numbers. So because it's in base 6, so it's going to be 2 times 6. Then append means you are going to add the other one plus, this is the first one, 2 times this base, this is 6. The next one is 2 times 6, another 2, that is it. Then the next one you have what, plus, append another one, 5 times 6. So the next thing you are going to do here is you are going to add a power. Now the power will start from the left side. The 6 you multiply it with, you're going to put a power on it to start from the left side. From 0, you count from 0. So at the top of this 6 is going to be 0. Here is going to be 1. Here is going to be 2. So in this we are expanding in a base 10 number. That is, we want to turn into ordinary number. That is base 10 number. So ordinary numbers are always in base 10 number. So if someone say, okay, expand 225 base 6 to expand, just expand it, means you are going to multiply each of them. These 2, you are going to multiply it by 6. The other 2, you multiply it by 6. 5, you multiply it by 6. Then you now, power is very important. You start from 0, from the back. 0, 1, 2, or from the right side. That is expansion of base numbers. Now, next thing is said, types of base numbers. There are a lot of base numbers. They can give you base 3, base 5, base 7, base 9, anyhow, any number they can give you that. We have octa base. When you hear octa, it is talking of base 8. That is number that is in base 8. That is octa number. Octa means octagon. That is number in base 8. Denary or decimal number. Denary or decimal number is just like your ordinary number, your base 10 number. That they may give you like 567. If sometimes they will write 10 at the bottom, sometimes they won't write 10 at the bottom. It is in base 10 number. Decimal number or decimal base, when you contain decimal points, you are still going to look at that as the lesson progresses. And binary. Binary is talking about number in base 2. Bi means 2. So binary means number in base 2. Then we have bisimal. Bisimal means decimal points number. It also has its own is that best decimal number or fractional number. So I want to look at how to solve this also as the lesson progresses. We have duodecimal. Duo means duodecagon. That is 12. Duodecimal means number in base 12. We have hexadecimal, number in base 16. There are lots. They have more than this, but you have to understand each of them. Once you understand each of them, you can be able to tackle the rest. That is it. So when you are using hexadecimal, you are going to apply what they call when you get to 10, because hexadecimal, one thing about number base is that if somebody give you number in base 5, let's check this together. If assume, let me clear this please. So let's assume someone give you number in base 5. Sorry for to clear the frame. Okay, now if someone give you number in base 5, if you are giving number in base 5, that would be, let's say 2, 4, 1 in base 5. Now this numbers is in base 5 because number, you cannot have something like 6, 3, 2 in base 5. This is actually 1 because number in base 5 is they must be less than 5. The numbers that make up that number must be less than 5. It means 6 is more than 5. So this number, it is what? It is totally 1. This can't be a number in base 5. It is wrong. But this is wrong because all these numbers, they are less than 5. So that is that. For hexadecimal, it's talking about base 16. So if you have like 5, let's say let's assume now you have 5, 6, 7, then you have 16 here. Let's assume you have 16 here. Now these are base 16 number, but what if you want to write like base 16 number means 15 is part of it, 14 is part of it, 13 is part of it, 12 is part of it. So how do you now write 16? What do you write 15 here? How do you write 14 here? You are going to represent them with letter. But as lesson progresses, you will understand how to do that. Well, our first lesson now will be how to be based on our learning objectives. We're going to look at how to conversion of other base number to base 10. So the first, let me copy this. Sorry for this. So let me copy this. I will explain it as I'm going. So I want to convert this. What if you are given something like this? Said you should convert this. Let me clear this frame. Now let's assume you are given something like this. You have to convert this. Sorry for the inconvenience. Or maybe I should just type it. If it's not showing, I will type it. So let's assume you are asked to convert these numbers. You have 1, 0, 1, 1 or 5, okay? 1, 0, 1, 2, 3, 4, 5, base 2. So you have to convert this to, let me give it color white. Okay, I think this one should be, okay, that means base 2. But in your notes, the 2 will be at the bottom. But this, because of we are using Jamboard, and it's more of something that, okay, now you have to convert this number is in base 2. At least the 2 is at the bottom here, so you have to convert it to base 10. So how do you go about it? Now you know the 2 is at the bottom. This is what you're going to do. All you're going to do is very simple. So you come here, you are going to multiply each of this number by 2. So the first one is going to be 1 times 2. Then the next number is 0, right? Plus 0 times 2 plus 1 times times 2. You have how many 1 there? 1, 2, 3, 4, 5. That's 5, 1 plus 1 plus 1 plus 1. So plus 1 times 2 plus 1 times 2 plus, sorry for bringing it down here, 1 times 2, 1, 2, 3, 4. I think it's the remaining one, right? Plus 1 times 2. So since you're multiplying each of them, you're multiplying each of them by, let me clean this. This two looks horrible. Okay. So 1 times 2. So in this now, next thing you're going to put, I told you when we did the expansion, then you start from this back, you had a 0. So it's just one's going to be 0. The second one is going to be 1. This is going to be 2. 2 is going to be here. Here is going to be 3. Here is going to be 4. Here is going to be 5. And here is going to be 6. Okay, now this is how you expand this. Now you have to simplify it. Now 1, this one, 1, the first one, 1 times, now 2 raised to the power of 6 is 2 in 6 places. That is 2 times 2 times 2 times 2. And 2 in 6 places will give us 64. So 2 in 6 places will give us 64. 64 plus, now 2 in 5 places, that will give us 32. So plus, sorry for this thing, what I'm running at the bottom is times what? Times 32 plus 1 times 2 raised to the power of 4 is 16. 2 raised to the power of 4 is 16. So plus 1 times 16 plus 1 times 8. 2 raised to the power of 3 is 8. 2 times 2 times 2 is 8. Plus 1 times 4 should be 8. Oh my god, sorry. Okay, you know it's 8, no problem. Plus 1 times 2 plus 1 times, now 2 raised to the power of 0, though mathematically you will still understand this as it progresses in your class. 2 raised to the power of 0, just take that any number, not any number, 0 raised to the power of 0 is undefined, but for now just take that any number at your level now, any number raised to the power of 0 is 1. No, mathematically 0 raised to the power of 0 can be undefined, but you just assume now. Now 2 raised to the power of 0, not assumption, is any number greater than 1, greater than 2 is 0, or is 0 raised to the power of 0. As for now, take it as 1. Do you understand? Any number raised to the power of 0, take it as 1 for now. But that does not mean it's mathematically correct. But as it progresses in learning mathematics, you understand why some are not mathematically correct. But at your level now, based on these levels you are, so 2 raised to the power of 0, it is what? It is 1. So it's not, it must be 2, it can be 5, it can be 100, any number raised power 0, it is 1 for you as for now. Don't take it as a theory or a law. Now let's now add all of them together. You see what we get now. Now 1 times 64 is 64, right? 0 times 32 is 0. Any number times 0, it is 0. So we have 64 plus 0, this is plus. Now 1 times 16, that is 16, plus 16, and 1 times 8, that is 8, and 1 times 4, that is 4, and 1 times 2, 1 times 2 is 2, and 1 times 1 is what? That is 1. I'm going to manage this place. That is 1. So this is it. So 64 plus 0 is 64. 64 plus 16, that should give us I think that should give us 80. 80 plus 8 is 88. 88 plus 4, that is 92. 92 plus 2, that is 94. 94 plus 1 is 95. So your final answer here is 95. 95 number in base 2 towards to base 10 number. So that is that for that. Let's look at another let me clear this, copy this, then pause the video and copy this. Now let's look at another. Let's assume now you are converting let me clear the frame. They ask us to convert this. How I'm going to write this now, so to avoid that, so let's assume you are asked to convert 2 3 symmetry 2 3 4 sorry, base 5. You have to convert it to base 10, to base 10. Now I want you to try this on your own. Let me see your final answer, but to save us time, so I'm going to multiply each of them by what? By 5, because in base 5. So it's going to be 2 times 3 plus 3. Sorry, it's 2 times 5. It's a mistake here. It should be 2 times 5. Let me clean this off. My bad. This should be 5, not 3, because it is in base 5. So here should be 2 times 5, 3 times 5, times plus plus 4 times 5 times 5. So this is it. So this is going to be times. So next thing is that you put power on each of them. So here is going to be 0, here is 1, and here is 2, right? I think we are right with this. Now next thing should be 2 times 5 raised to power 2 is 5 times 5, not 5 times 2. Be careful. 5 times 5. That is 5 times 5 is 25. Then plus 5 raised to power 1. Any number raised to power 1 is that number. So that's going to be 3 times 5 plus, I told you number raised to power 0, it is 1. That will be 4 times 1. So now let's move on. So 2 times 25 is 50 when you use the calculator. So this is going to be 50 plus 3 times 5 is 15, then 4 times 1, so this should be 1, this times 1, 4 times 1 is 4. Okay, see my 15 look like, so remember this is 15. Hey, this is bad, horrible bad, this is horrible. Let me clean it off. Let me clean it off. Sorry for this. This 15 looks horrible, so I don't want it to like. The 5 looks horrible. Sorry. So this is gonna be this 15 here, this 5 here. Sorry. Okay, now 50 plus 15, that is 65. 65 plus 4 is 69. So this is gonna give us 69. 69 base 10. 69 base 10. So if calculated yours, no problem. So I guess you did it on your own and you get it right. So this is conversion from, this one is in base 5 to base 10. So with the first one we did, we will convert it from make this 10 should be base 10. So yeah, sure. Now it's base 10. So that is that. Now the last one now under this particular question is that what if you are given an unknown? It's not every time they're going to give a number as a base number. Let's assume you are given, let's say, convert, let's say x is unknown. 4 3 1 4 3 1 base hex. Now it is not hex, it is no more number now to base 10. So base to base 10. Okay, so base 10. Now, so how do you do this now? The same thing you're going to apply. The way you multiply numbers, what I'm going to do here. So you're going to multiply each of them by x. That will be 4 times x plus 3 times x plus 1 times x. So next thing is that the power I told you about, there is going to be 0 here, second one 1, and the third one is going to be 2, right? Now 4 times x squared is 4x squared. 4x squared. 3 times x raised to power 1 is x. So x squared raised to power x squared is x squared. So 4 times x squared is 4x squared. 3 times x raised to power 1 is x. So 3 times x, that will be plus 3x plus 3x plus 3x plus, now x raised to power 0, I told you any number it can be letter. Raised to power 0, it is 1. So 1 times 1 will give us what? Give us 1. Plus what? This plus 1. So this is your final answer. This quadratic expression. You cannot say 4x squared plus 3x plus 1s and it give us 8x squared. No, you can't do it. You can't do it. No, this is algebra. You cannot, unless they have the same power. The letter attached to them, they are the same letter and they have the same power. So that is when you can add them up. For rules of addition, you cannot add these things together. But if there are ways of you can factorize this using quadratic expression, but this is a final answer. Now we are done with this. I'll move on to the next one, which we are going to look at on conversion from base 10 number to order base. What we did there is we convert from order base to base 10. So we look at conversion from this base 10 to order base, that is the reverse of what we did here. So let's move on to the next one.